Hello guys, today we will be discussing your first laboratory. So in today's laboratory, we would be able to come up with a simple circuit using your breadboard. Okay, so we will be using resistors, and then of course we will be using also the voltage source. We have equipment for the voltage source, and then we will be using multimeter, and then these will be discussed in a while. So as we go on with our laboratory, so we are given a circuit. So this is the kind of circuit that we are going to do. Okay, it's one, and then we're going to solve that one in a while, and then we plot it in a breadboard, and then we test the values using the different laboratory equipment. So let's start. So this is the circuit that we are going to solve, and then in a while we are going to plot this one using the breadboard, and then we are going to measure all the values such as the current and the voltages using the digital multimeter in a while, no? So meantime, so that there will be a comparison, we can compare whether our values using the digital multimeter is just the same with this one, yung isosolve natin siya manually. So first is that we are going to solve the values here, the required values, manually, okay? Using the formulas na naituro sa inyo sa circuits ninyo. So, first is that we have to evaluate the circuit. As you can see, the circuit, we have a voltage source here, 820 volts, and then we have there are 5 resistors. We have 1.2 kilo ohm, 2.2 kilo ohms, 9.1, 3.9, then 8.2. You can see R4 and R5 are in parallel, then R2 and R3 are in parallel. Okay? So, the easiest way is that I'm going to attack the problem as like this. I-solve ko muna tong dalawang to as parallel. Okay? And then these two as parallel. Tama ba? So, here is R2 is in parallel with R3, and then R4 in parallel with R5. Okay? Alam nyo naman magkuha sa circuits nyo yan, di ba? Yung formula sa calculator yun is 2.1 kilo ohm inverse plus 3.9 kilo inverse, and then inverse of the answer. Okay? So the answer here is, solve natin, 2.2 exponent 3 inverse plus 3.9 exponent 3 inverse of the answer, that is 1.41 kilo ohms. Okay, then as well as here 9.1 kilo inverse plus 8.2k inverse, then inverse of the answer, that is equal to inverse plus 8.2 inverse, then inverse of the answer 4.3 kilo ohms. Okay? So, ibig sabihin, if you're going to redraw that one, just the same as 4.3K, 4.3, that is 1.41K ohms. No? So, pwede mo nang makuha ngayon si I.O. mo dyan. So, ang remaining, natin dyan is, I'm going to redraw that one, guys. Dito na lang sa baba. Okay. So, we have this one. Ilan to? 1.2. 1.41K. This is 4.3K. Ohms. Okay. Then we have 20 volts here. Una, so I.O. daw yan. Kunin natin si I.O. Okay. I.O. So, that is, so negative ito, no? So, negative 20 volts plus 1.2K I.O. plus 1.41K I.O. plus 4.3K I.O. KVL tayo, no? So, equals 0. Then, magiging I.O. now is equal to 20 divided by 1.2K plus 1.41K plus 4.3K. And that is equal to, ilan ang IO natin? 20 divided by 1.2 plus 1.41 plus 4.3 exponent 3. That is 2.89 milliampere. Okay? That is our IO. 2.89 milliampere. Pause mo pala ba zaman? Okay, so next is that we need to solve for the other currents and then the other voltages, no? So, yung kay R1, we solve I1. Okay, i-dub natin siya as I1, then R2 sa I2 natin, then R3 for our I3, and then the current that flows through I4, that is, our resistor 4 is I4, then we have I5. Yun yung mga unknown natin. Going to erase this one ha, para malinis. Okay. We know, nasolve na natin na ang IO natin, so yung current na nagpo-flow dito is 2.81. So yung I1 natin is ito, di ba? I1 natin. So that is the same as IO pa rin. Tama ba? So IO is equal to your I1, so that is 2.89 still milliampere. Now, we cannot solve immediately the current of our R2 and R3 kasi kinuha natin yung parallel na equivalent nila. So, but there we can solve for its voltage. Tama ba? 'Di ba ang voltage is equal to your I and R. Okay? And so with your voltage 1. So with your voltage I1 times your resistance 1, so 1.2. So V1 now is equal to 1.2K times 2.89 milliampere, and that is equal to 3.468 volts. And then itong V2 natin tsaka V3 natin, kunin muna natin yung voltage natin kay 1.41. 'Di ba? Guys, 'di ba pag parallel, okay, 'di ba pag parallel is same, 'di ba ganyan? 'Di ba pag parallel class, 'di ba ang voltage dito is just equal to the voltage here. Okay, voltage drop here is equal to the voltage drop kung saan siya nakaparallel. So, since the 1.41 na to is a parallel between R2 and R3, so that means class, the voltage here would be equal to your voltage in R3 kasi parallel lang din sila. So, since meron na tayong current na na-solve dito, we just multiply it to 1.41, and that is now the voltage of your, na meron kay resistance 2 tsaka kay resistance 3. Okay? So, for R2 and R3, so for V2 and V3, they are equal, which is equal to your current 2.89 milli times 1.41 kilo ohms. And that is 4.07 volts. Multiply ko lang ha. Times 1.41. Yeah. 4.07 volts. So that is 4.07 volts. 4.07 volts. And then same is true with your V4 and V5. They are the same kasi they are in parallel. So, kung may parallel 4.3 times your 2.89. By the way, ay sakto, 2.89. Okay? So current mauna, no? So it's 2.89. Though they same lang naman kasi sila, that is commutative property. Times your, saan yung total ng resistance natin? 4.3. Okay, that is equal to 2.89 times 4.3, 12.43. 43 volts. Okay? That is 12.43 volts, 12.43 volts. Okay? Sir, how to solve for the current na din po? I2. Okay, from our Ohm's law, so we can solve for our current that is equal to V all over R. Okay? So you have your voltage na, you have your resistance. So divide mo sila, you can solve for your current. So for your I2, So, consider natin si V2, that is 4.07, divided by the resistance 2.2, okay? So, that is 4.07 divided by 2.2 kilo, that is equal to 1.85. Okay, pwede nyo i-solve ulit to ha, 25 milliampere. And then yung I3 natin, so that is the voltage 4.07 divided by your resistance 3.9 kilo, that is equal to 1.04. And then your I4, that is 12.43 divided by your resistance 9.1 kilo, that is equal to 1.37 milliampere. And then the last one, I5, that is 12.43 divided by 8.2 kilo, that is equal to 1.52 milliampere. Okay? So, ganyan natin siya isolve manually. Then mamaya, by using the laboratory equipment, palabasin natin itong mga values na to. Then we compare if they are the same or not. Okay? So, gagawin natin tong circuit na to sa breadboard, using breadboard. So, we solve already the circuit manually. Okay? We were able to come up with the different values, required values. Now, we use this equipment to test whether those values are correct. No? So, we have here, this is a voltage source. Okay? This one, okay? I hope you know all this. This is a breadboard. So, we'll be using these alligator clips. These are called alligator clips. We will be connecting this one from our voltage source up to the breadboard. And then, of course, we have our resistors. Okay? Resistors, marunong naman na kayo dyan mag-solve, di ba? So you can still remember yung black boys rape our young girls, but Violeta gave willingly last time. And also, that was taught in your physics. And we are not going to measure it with those kind of computation manually. We are going to use this one. This is called the... Doesn't kindly open this one for me? This is called that is called the, okay, this one is called the digital multi-tester. This is digital. We just need to connect it. Okay, there are this one. We just need to connect all these to our resistors, and then we can be able to get the values of our resistors. Okay, and in the digital multimeter class here, we can also solve for the voltage. Okay, then the resistance, the frequency, and then the current. Okay, so that's it. So we have the voltage source, we have the breadboard, we have the alligator clips, the resistors, and then the, what do you call this one? This is our digital multimeter. Okay, so may I just emphasize, this is the breadboard. I just want to emphasize the connection of this. Okay, kasi kung makita nyo, maraming, hindi to skyflakes marami siyang butas-butas, and then may mga divisions. Dito sa pinakadulo class, okay, merong 2 columns dito. These 2 vertical ones. Itong pababa, they are connected in series. Okay, itong pababa na to, they are connected in series, pero walang connection ito dito sa kabila, dito sa right niya. Nagigets nyo? Itong left, magkakonnect sila, they are connected in series, dito sa right niya, parallel naman sila dalawa dyan. So, they are not connected to one another. The same time, hindi sila connected dito sa baba nito. I'm sorry. They are connected. Okay? Itong buong pababa na to, lahat sila series together. Okay? They are connected to one another. Ang point ko pala dito, hindi dito connected. Okay? Dito naman sa malalaki, itong taas na to ang connected together. They are series. Okay? Ito naman. Itong paside naman, horizontal. They are connected to one another as series. Okay? Itong pababa naman as parallel. Okay? So, yan yung connection niyan. So, gagamitin natin dyan, i-connect natin tong ating mga resistors. Cut. Okay, so dyan sa circuit natin, hanapin natin si 1.2 kilo ohm, 2.2 kilo ohm, 9.1 kilo ohm, 3.9 and 8.2 kilo ohm using our digital multimeter na. So, first is, ilagay mo muna, iset mo itong knob natin. Palabasin ko lang itong ano. Itong knob natin, so since ang kailangan natin is ohms, connect natin sa ohms. Okay? So, may lalabas na ganyan. So, wala namang problema kung red or right ang left or right natin. Okay? Ang concern lang natin dito later on pag nag-test tayo ng voltage at saka ng current. Pero sa resistance, wala naman siyang polarity. No? Okay. So, try ko to. Kung ano kaya to. Okay? This one, try ko lang. Okay, that is 9.3 kilo ohm. Meron ba tayong hinahanap na 9.3? That can be considered na class yung si 9.1. Kasi nga, 'di ba pag ano tayo yung meron siya yung plus minus ganun na 5% ganun. So yung 9.3 since 9.3 siya malapit siya ka 9.1, ito na sa ating R4. Okay? Na measure natin. Next, mag-measure tayo ng iba. This one. Ano to? 1.8. Meron ba tayong hinahanap na 1.8? Wala. Dami naman natin i-test. I-test natin lahat to. Dapat pala na ano na dati. Okay. This one. 3.8. Ayun. Kailangan, meron tayong sa R3. Need natin si R3. That is 3.9. Okay? So, yun. Next. $7.9. Kailangan ba natin ng 7.9? Hindi. Cut mo lang. No? After testing everything class, so ito si resistor ni 1.2 kilo ohms or si 2.2, this is 9.1, this is 8.2, and this is 3.9. So that is the magic of that digital multimeter, no? We could be able to solve immediately or identify immediately the value of our resistance. Hindi na natin kailangan pang isolve ng black boys raped our young girls, but Violeta gave willingly yung ating last time na ginamit to memorize yung ating ng mga values natin. Okay? So the next thing is we plot it here sa ating breadboard. Okay, gagayahin natin yung circuit, i-plot natin dito sa ating breadboard. Of course, you need this long nose. Okay, we need the assistance of this. Okay? Okay, so first is that we have to connect R1 and R2. Note that R1, yung isang paa ni R1, is connected sa isang paa ni R2. So first is that ipasok natin si R1. Okay, that is R1 na. Okay? And then, yung isang paa niya is connected kay R2. So, puno mo sa R2. Yan, that is R2. Yan, yung paa niya is naka-series kay, connected siya kay R2. Okay, ang next natin, si R2 nakakabit na, yung sa baba na part ni R2, connected siya sa isang paa ni R4. Yan. O, ganun lang class. Pag connectin mo lang yan. Basta dyan sa malaking part, yung horizontal part, sila ay series. Okay, magka-connect yon. Ay, hindi siya series. I mean, magka-connect sila. And then, yung sa isang paa ni R4, connection siya kay R3. So, yun. So, ang magkakadikit ang paa is si R2, R4, tsaka si R3. Diba? Kaya dapat magkakatabi ang mga yon. Yan. Tingnan nyo, magkakatabi yung paa nila. And then, si R5 connected sa isang paa ni R3 at isang paa ni R4. Okay. So, ibig sabihin class, itong circuit na ito, pag ilatag natin sa breadboard, may ganyan tayong kakalabasan. You can have your own design, okay? As long as same yung connection niya. Kung gusto mong mas masikip sila sa isa't isa, okay lang. Walang required na number of holes na gap sa kanila. Okay? Okay, next goal natin class is that i-connect na natin to. Connect the circuit above. Okay, turn on the DC power supply and set it to 20 volts. Measure the voltage drop. Okay, may measure na natin yung voltages dyan. If we are going to connect that one into a 20 volt voltage source. Now, anong gagamitin natin na voltage source? Ito po. Okay? So, pwede natin yung iset sa 20 volts. Merong knob dyan. Okay? Yan, current yung sa left, voltage yung sa right. Okay, iset lang natin yung voltage into 20 volts. Okay. 20. Okay, so that's 20 volts. Now, we connect it to our breadboard, simulation board, using our alligator clips. So, we have our alligator clips there, but we need to check if 20 volts ngayong lumalabas using our okay, so meron siyang 20.41. So, that is, nag-lapse yun, and that is just okay, that is tolerable naman. Okay? So, ngayon, using the alligator clips now class, okay, so we connect it to our breadboard, okay, so, still class, ang red is for the positive one, so saan ang positive? Doon sa isang paa ni R1, so doon natin i-connect yung red, so that is positive, okay, positive, mas malaki yung line, okay, connected siya sa kay R1, and then yung paa ni R4, connected siya kay negative. So that is for the black one. Okay? So yung circuit natin with 20 volts, the voltage source, ayan na siya. Okay, yung red is positive, connected siya kay R1, then yung negative connected siya kay R4, yung paa ni R4. So to start, we measure for voltage 1, okay? We connect yung ano natin, yung ating tawag nito, digital multimeter, kay sa may R1, kay sa mga paa ni resistor 1. Okay? Then sa other paa. Okay, and then we check it. That is 3.47 volts. And ang na-measure natin kanina is 3.468 or that is 3.47 volts. They are the same. Okay, next one naman, we have the voltage 2. Okay, so that is the voltage across the resistor 2. So, i-check mo lang, connect mo yung ano natin. Okay, sa paa ni resistor, sa mga paa ni resistor 2. And then that is 4.13 volts. Okay, that is 4.13 volts. And then, ang na-measure natin kanina manually, that is 4.07 volts. So, there is a difference of 7, 8, 9, 10, 11, 6.06. And it's just okay, no? A minimal difference. And then, voltage 3. So, the voltage across, resistor 3. So, same pa rin, ganun lang gagawin natin, i-connect it, and then the measurement, 4.13 volts, and then see, that is 4.07 volts, diba? Kung makikita nyo class, sabi natin that R2 and R3 are parallel, so parehas silang nakuha is 4.13 volts, okay? Kasi they are parallel. Next, the voltage 4, ang nakuha natin is 12.43, so that is the voltage across R4. So we check it. And nakuha natin is 12.77. And it's just okay. Okay? Minimal lang. 12 point something. 12.77 versus 12.43. Then we check if it is 12.47 din sa ating voltage 5 kasi they are in parallel. That is 12.77, 12.77. And they are right. Okay? So, how about for the current? Okay? So, let's do it. So, the next one class is that we are going to solve for the current naman. So, using our digital multimeter. So, from its previous na setup na voltage, we turn it to sa may MA or that mag-measure natin ng amperes or milliamperes, that is for the current. Okay, so that's now ready. Ngayon, hindi siya parehas ng process doon sa pag-solve ng ating voltage. Dito, if we're going to solve for our current, guys, tatanggalin natin yung isang paanong resistor and then isi-series natin siya, okay, doon sa isang paanong susundan niya na resistor kung saan siya nakakonect. So, for example, that one. Yung resistance 1, yung resistor 1 na yan, para ma-solve natin yung current niya, okay, tinanggal natin yung isang paa niya. Hindi yan nakakonect ha, nakataas yan. Okay, nakataas yan. Ngayon, yung test probes natin, okay, idikit natin yung isa doon, which is yung red one natin, i-connect natin doon sa pupuntahan niyang resistor. Kumbaga, isi-series natin siya, palalakarin natin yung kuryente doon sa test probe natin. Okay? So, with that, ang makukuha natin is, using our digital multimeter, that is 2.9 milliampere. Ayun may M, doon may M. Okay, that's 2.9 milliampere. Wherein yung na-solve natin kanina, that is 2.89 milliampere. Di ba? Ang perfect, parehas lang. 2.9, 2.89, they are just the same. Now, we have yung I2 natin. I2, so that is the current sa may ating resistor 2. So, ibalik mo class, ibalik mo yung original setup. Okay? Yung paa naman, nung sa baba, okay? Ang next na tatanggalin, okay? Doon natin ipapalakad ngayon yung ating test probe. Isi-series natin siya papunta naman doon sa next na pinag-connectan ng paa. Okay? So, yung red na test probe, doon sa pinagtanggalan natin. Okay? And then, i-connect natin siya doon sa nakakonectan niya originally. So, that is 1.86 milliamperes. And ang na-solve natin kanina is 1.85 milliampere. Okay? They are just the same. For our current 3, our target is 1.04 milliampere. So, same thing. That's what we are going to do. Okay? So, next, the current passing through resistor 3. So, what we have solved while back is 1.04 milliamperes. So, same process. Ang nakuha natin okay, that is 1.06 milliamperes. Okay, they are just the same. Okay, and then the current for ay 1.37. So we hang yung ating isang paa ni resistance 4. So hinang natin, ayun, nilipat natin sa kabila, or pwede nyo lang ihang yan. Okay, and then we connect it to R5, yung ating test probe. Okay, then let's check the value. That is 1.36. Okay, 1.37. And the last I5, that is 1.52. So ibalik mo yung original circuit. Then we hang, okay, we hang the other, yung isang paa niya. And then, we measure it again. And then, tada! That is 1.56 milliamperes. 1.52 milliamperes. Okay, the difference is pwede nang patawarin. Okay? So, they're just the same. So, that is the process to measure the current using our breadboard, this equipment. Okay? We have the digital multimeter, the breadboard, and so on and so forth. So, please don't forget to subscribe. Wow. There you have it, our laboratory 1. Please don't forget to like and subscribe. If you have question, please just message me.
Yes.